Here is a question under sequence and series. If A and arrow are both positive, we have to find the sum of the series log A plus log A arrow plus log A arrow squared down till log A arrow to the n minus 1. First of all, what type of sequence is it? Is it an arithmetic sequence or a geometric sequence? Okay, let's verify. For arithmetic sequence, we have common difference, and for geometric sequence, we have common ratio. Common difference says second term minus first term. So if I say log A arrow minus log A, what will it give me? This will give me log, I will divide A arrow by A, by the law of logarithm, A arrow over A, and that will give me log arrow. Alright, let me verify this by saying third term minus second term. Log A arrow squared minus log A arrow is log A arrow squared divided by A arrow. And this will still give me log arrow. Here we cancel A, arrow squared divided by arrow is arrow. And if we do this minus this, we are going to get log arrow also. It means that the sequence is an AP, arithmetic sequence. So the first term of the sequence is log A, and the common difference is log arrow. Alright, we are looking for the sum of the series. For sum, Sn is equal to n over 2 into 2a plus n minus 1 times d. A is log A, d is log arrow. So I can simply say Sn is equal to, alright, since I have the nth term of the sequence already, that's log A arrow to the n minus 1. You know, the nth term of the sequence can actually help us determine any member of that sequence. For example, if I want to determine the first term, here n is equal to 1, I'll plug in 1 here. 1 minus 1 is 0. Arrow to the power of 0 is 1, so I'll be having log A. That's the first term. For the third term, I'll put 3 here. 3 minus 1 is 2, so I'll be having log A arrow squared, and that's the third term. So I have the nth term already. The formula is n over 2. I can reduce this formula into A plus U sub n. So Sn is n over 2, n is still n, A is log A, U sub n is log A arrow to the n minus 1. Alright, let's simplify this. This is Sn equal to n over 2 log A plus log A arrow to the n minus 1. That the law of logarithm will multiply the two numbers. That's log A times A arrow n minus 1. And this is equal to n over 2 into log A times A is A squared. So we have A squared arrow to the n minus 1. By the law of logarithm, A log B is equal to log B raised to power A. So this n over 2 here, at the back of this log, I can remove this bracket now. Okay, I can remove it. This n over 2 here is going to stand as the power of everything here. That will be log A squared arrow to the n minus 1, all raised to the power of n over 2. Okay, you get the point now. So this n over 2 here is affecting the power of A and the power of arrow, which is n minus 1. So I'll write log A 2 times n over 2 is 2n over 2. Then arrow n minus 1 times n over 2, that's n into n minus 1 all over 2. You get it now. So 2 cancel 2, right? What do we have now? It means that we have the logarithm of A, alright, to the power of n, then arrow to the power of n into n minus 1 over 2. N into n minus 1 all over 2. See, n is common, so I want to bring it out to be log A arrow to the n minus 1 over 2. Since n is common to both powers, I'll just bring it out like this. Okay, so taking the reverse of the law that we applied here, when we said this n over 2 will become the power of a squared arrow to the n minus 1. The n can come back. You see, we are trying to write our answer to be in the format in which the options are given. So if this n comes back, it will be n log a arrow to the n minus 1 all over 2. And this gives the nth term, the sum of the first nth term of this series. All right.